All right, this is a test to see if can everybody hear me? Yep. All right, sounds good. So, my name is Caren, and today I'm going to be talking a little bit about audio on Android. A little bit about me. I'm coming from San Francisco, and this is my first time in Italy. Before I came to Italy, the only word I know was allora. I heard that's a pretty common word, and if you know that word, it's enough to get around pretty much. So I've heard it talked a few times, so I'm just going to say allora whenever I don't know what else to say. So I currently work at a company called June. June is a smart oven company, and what that means is we have an oven and it has a camera inside, and it's cool because the oven can detect what kind of food you put in it and automatically cook your food. So for example, you could put in a piece of steak, and we use machine learning to detect that you did indeed put in a piece of steak, and we can automatically cook it for you. So you can imagine this is pretty useful for people like me who can't really cook well. You can put in like salmon, you can put in like vegetables, and automatically the oven can detect what you put in and cook it for you. So a lot of what I ended up doing was implementing audio for the oven in general, and that's how I kind of got started into looking into audio for Android. So a little bit about why I think audio matters at all in Android is because most of the times people think, oh, isn't audio just kind of something that annoys users? Like usually people don't want audio in their apps because they just want to turn it off. So shouldn't we kind of just let the Android system handle our sounds instead of having to implement this ourselves? But I think audio is actually a really cool thing because if you think about it, if you ever played a game without sounds, it's a completely different experience. Like 90% of the fun in games is kind of the audio, the soundtrack, the sound effects that come with it. Or if you ever watch a scary movie without sound, it's the same thing. It's not very scary if you don't have the sound going on with the soundtrack in the back. If you watch a scary movie without the sound, it's almost not scary at all. So sounds and apps really makes things a lot more fun for users, and it turns a machine into something more alive. So for example, if we have sounds on the oven, I think it makes it easier for the users to connect with the oven in general instead of just thinking, oh, this is another computer I have in my kitchen. Another cool thing about audio, I think, is that it allows for users to personalize this device that they have. So we want something that lets users feel like this really belongs to them, and we want to feel like it's part of their home. And another thing is that research has shown that apps that are able to be personalized is a lot less likely to be uninstalled. So if a user can personalize your app, it's a lot less easy for them to replace your app with something else because then they would have to go through all this customization again. So users really like it a lot more when they feel like they actually have control of the app they're using, and so we want to give them more options to personalize their experience. Another thing that I think audio is really important is for guiding the users in general. So it's really great to give feedback on user actions to inform them of what is happening. So for example, if you're playing a game and you hear like a money-making sound, then you know you did something good and it's a positive thing. But you could also have like losing life sounds or losing HP sounds where you get negative effects. So whenever you hear these sounds, you kind of get an understanding of what's going on in the game and how you're progressing in the game. So in the case of the oven, we make sounds for when your food is ready, or when the oven is done preheating and it's time to put your food in. So in this case, the users would know a little bit more about what's going on with the oven and how they can interact with it. So to kind of start off about how we should start implementing audio, one of the things that's good to look into is how audio is processed in the first place. So how audio is processed is pretty cool. So it starts with, you can see a person who creates some sound waves, and this is then converted through a digital analog from analog to digital, and then stored in the computer in some way, so that when you want to play the audio again, it goes through this digital to analog converter that eventually comes out of a speaker. But the one thing that we really only care about is this idea of latency. So latency is the delay as a signal passes through a system. So what does that really mean is you have some sound file on your device. It could be your phone, it could be your computer. So the file is on the device. It goes through some process, and eventually it gets through your headphones. So if you think about it, latency on Bluetooth is probably a little slower than latency on a headphone that's plugged in, just because it has to go through a little more. So if we look at this a little closer, from the application, it's where the audio source is. So this could be like an audio file that's taken from the device. It could be like an MP3 file, or it could be a WAV file. This could be already stored on disk, or it could already be downloaded, or it could come from HTTP requests if you're streaming music. So at this point, we've already converted this analog to digital, and we have a digital file. So from there, after the sound file is on the app, it goes through the audio framework. So the audio framework does a couple of things. First, it resamples the audio file and then adds effects to it, and then it kind of mixes it to put in one full stream of everything the system should be playing. So the graph is an example of what sampling is. So the graph is like the wavelength of the audio, and every dot is how many times you want to sample it. So the more you sample it, the more dots there will be in the graph. And finally, it gets to the hardware, which is the digital to analog converter, and that's how we finally hear the sounds. So the interesting about this is that audio hardware, it consumes data at a constant rate. So what this means is that when we pass audios to be played, we have to make sure it gets processed in time so it can meet these deadlines that the system has for us. If we miss these deadlines, then we get silent sounds and your audio isn't played, or you start getting these weird like static sounds that sounds like the audio file is corrupted or something. The way I like to think about it is there's this really cool YouTube video from this Googler about how audio is processed, and the analogy he kind of uses is that there's this chicken trying to cross the road. So why does the chicken want to cross the road in this case is because it wants to get sounds played. So there's a chicken trying to cross the road, there's a gate blocking him. At the same time, there's these cars coming at constant speed. So the cars are driving, they're at the equal distance apart, and they're constantly driving across the road. Another factor is that we have an Android system trying to control whether sounds get played or not. So the Android system is the person opening the gate and closing the gate. So it's determining when the chicken can actually cross the road. So if the Android system says, okay, you're ready to be played, the chicken then can cross the road. But the problem with this is the Android system has a lot of things to handle, right? It could be making network requests, it could be rendering stuff on the screen. So he may get too busy and not be able to open the door at all at the right time. So if he opens the door at the wrong time and the chicken thinks, oh, I can cross the road, in which case the audio is like, oh, I'm ready to be played, and it's the wrong time, it's going to get corrupted. Because it could either get run over by a car, in which case it will play a weird static sound. So that's kind of how I think about how audio is processed in general. So now that we know a little bit about how audio itself is processed, we could kind of look into how we can do the audio playback itself. So when I was looking into this, there wasn't many resources about how you could get started with audio playback, but it seems like there were three main options that we could look into. So the first one was MediaPlayer. That seems to be a pretty common one. There was something called a SoundPool, which seems to be a little less common, but also pretty frequently used. And then there was a really popular library called ExoPlayer. So the first one I looked into was the MediaPlayer. This seems to be the most popular option and the easiest option for when you want to play audio files or any kind of media. So MediaPlayer is great in the sense that you can easily fetch, decode, and play audio with like minimal setup. It's about like 5 lines of code and you can play a sound file so easily. The great thing is that it supports stuff like local resources, or you could do like internal URIs or external URIs if you're doing some HTTP streaming. So just to give an example of how easy a media player can be to set up, here's an example method of if we wanted to play an audio file. So the first thing we want to do is we want to create the actual media player object. When we create this media player object, it actually creates a new looper and event handler that lets the system know, okay, we want to start accepting incoming sound requests. Once we do that, we want to tell the system what kind of audio stream we want to play. Like, is it going to be music? Is it going to be ringtones? Is it going to be sound effects? This is important because different kinds of streams have different kinds of volume control. So, for example, like music may be at a different volume than your ringtone, so that you may be able to hear like your alarm or when someone calls you more loudly than when you're playing music. Another thing is that based on which audio stream you decide that you want to play, it really affects like what kind of output the speakers from the phone itself is going to come out of. So now that we've created the media player object, we set the audio stream type, now we want to actually tell the media player like what our source is going to come from. So this would be the file that it's coming from or the HTTP URL that's going to come from. And after that, we tell the media player, okay, now we've done all the setup. We want to actually start preparing and be able to start playing. And once we've done that, we can finally say, okay, media player, now start the file that we've done. This will either resume whatever file you've started before, or you'll start from the beginning if you haven't played the file at all. So an important thing to think about is there's a lot of things that could go wrong when you're trying to play with the media player. And in this case, it would be really great to always think about a try catch block so that you could always release the media player when it's not being used. So you always want to release the media player, because if you don't release the media player, it's going to cause continuous battery consumption from your app, and the user's not going to be happy about that. It's basically taking up battery consumption for no reason. Another thing is that if you're still holding on to this media player object, other apps may fail when they try to play media. And one more thing is that it could cause unnecessary memory resource holdup if you're still holding on to this object that's not being used. So the complicated thing about media player, unfortunately, is that it's really complicated. So this is a state diagram of every state that the media player itself is in. Once you do the initialization and the prepare state, it's almost as complicated as like a fragment. So this is like the worst part about the media player, in the sense that it's really complicated to keep track of what state the media player itself is in and what you're able to do in each state. So since it's so state-based, it could easily cause like behaviors that you don't expect and you don't want. So let's take a look at what kind of states the media player is in every time you do something with it. So once you set the audio stream type, this is when you're like, okay, I'm going to start streaming music, or I'm going to start streaming some notification sounds. It's in this idle state, which means it's not ready to do anything yet, but you simply told it, okay, be ready for it, but we're not ready to play it yet. Once you set the audio path that says, okay, this is the type of media I'm going to play, it's only in this initialized state, which means it's almost ready to be played, but not quite. And finally, when you do the prepare state, this is, as the state says, prepared. And that's finally when you can do a start or seek to. So every time you do something with the media player and it goes into a new state, these are represented by int values in the Android system. And a lot of times, what people see is that they'll see this error that says something like, prepare cannot be called in state 1. So what that means is that you're trying to do some action in a state that it's not expected in. And this is kind of confusing to decode, because it'll be giving you these error messages with these random numbers and you have no idea what's going on. But what the Android is actually trying to tell you is that it's in this state that it doesn't expect, and states are mapped to integer values. So some common errors that are seen when dealing with media players, of course, not handling what happens when you get an error, perhaps like not actually performing the right actions, the right state. So you could be trying to play a media file when it's only in an idle state, and that will cause an error. And the other thing that's really important is not releasing the actual media player object after you use it, because this, as we talked about it a little before, it could cause like memory usage, battery consumption, or causing other apps to not be able to play the media files. So media player was great for most of our use cases where we just wanted to play like a single sound file. But then we came to this example where this is an example of a screen on the oven itself. It's kind of like a temperature slider, so you could determine like what temperature you want to start baking your food at. So if you can imagine, it's like a bunch of numbers from like 100 to 500. And we have these like major numbers like 325 and 350 and 375. So every time the user scrolls past those numbers, we want to play like a sound on the scale. So the experience we wanted was that you would flick the slider, and it would kind of be the same experience as if you were putting your hands over a piano and kind of just like playing the scale like that. So this was difficult because now we have to play multiple sounds at the same time, which Media Player doesn't support at all, because you can only play one file at a time with Media Player. So this is when I started looking into the second option, which is the SoundPool. So SoundPool is great in the sense that it's backed by the Media Player to decode the actual audio, but you can use a collection of samples from the actual APK. So it's loaded into memory, so you don't have to incur that cost of taking more time to actually load the media files before you actually play them, because that's just extra time before the user can actually hear the sound versus when we actually want it to be played. It's also able to manage more than one audio stream, so we could do something like sound mixing, where we're playing more than like one sound at a time. So you could play up to as many sounds as you want, so there could be like 5 different sounds playing at the same time. Another great thing about it is you could set the priority of when a sound plays. So for example, if you have some certain sounds that are more important than the others, you could set it in the SoundPool. You could say like, if we have an emergency sound that definitely needs to be played, it could have a higher priority than like a regular sound, like a tapping sound. So to look a little into how SoundPool works, we're going to look into a code example. So in this example, we have a SoundPool builder. The first thing we do is we set the audio attributes. And this is basically the same thing as setting the audio stream. Like, is it going to be coming from games? Is it a media sound? Is it an alarm sound? Is it a notification sound? And then we set the max streams we want it to play. So this means how many sounds do we want it to play at the same time? Do we want at most 5 sounds to play, or do we just want at most 1 sound to play? So if you set it to a max stream of 1 sound, that means that every time you play a new sound, the previous sound will automatically stop playing. If you set it to 5 sounds, that means you could play 5 sounds at the same time, but if you play the 6th sound, then the first sound you try to play will stop playing automatically if it hasn't finished yet. So once you create your sound pool, you want to start loading files into your sound pool so that it has this pool it could grab from. This is the part of the efficiency where you don't have to load things when you want to play it. You can load it beforehand, so you don't have to incur the cost of loading files before you play it. So to load actual files, you just pass in the audio path, and you get back this sound ID, which you can later use to actually play the sound. So when you play sounds with a sound pool, you pass in the sound ID that you got before from when you loaded the file, and you give it 2 volume sounds based on the left audio and the right audio. So the left audio player can be louder or less quieter than the right sound. And you tell it what priority is this based on, should this be less priority so it doesn't get played if another higher priority sound plays. You could tell it what kind, if you want it to be a looping sound so it could play continuously, and it kind of also define the playback rate. So if you wanted to play at twice the speed, it's going to sound really quick and kind of like high pitch, versus if you play it at like half the speed, it's going to sound kind of deep and really slow. So there's a lot of control you could have when you play sounds with the sound pool. So I didn't just figure all this out myself by determining, what should I do if I have more than 1 sound I want to play at the same time. So a really cool class to look into is the audio service. So this is just part of the Android open source project. So if you want to figure out how audio works in general on Android, this is a really great class to look into. So this is cool in the sense that it tells you exactly how Android itself is trying to handle audio. So for example, it tries really hard to deliver this responsive UI, which means most methods are asynchronous in it. So for example, if you update your sound volumes to like from 5 to 10 to make the sound volume a little higher, it actually updates it on a different thread than what the sounds come out of. Some other common stuff, or some other cool methods that I thought were pretty interesting, was stuff like low-touch sound assets, read audio settings, is camera sound force, and is in Zen mode. This really tells you a lot about how Android phones in general are trying to handle sounds. So MediaPlayer and SoundPool cover most of my cases, and so those were the main 2 methods that I used to implement audio. But the third option was ExoPlayer. So ExoPlayer is cool in that it's an open source project, so it's not part of the Android framework itself. So what this means is that you have the ability to update the player along with the application, because you could just upload it in your Gradle file, say the new version, instead of having to pull in a whole new API. And this also is great because then it means you have fewer device-specific issues across different versions of Android, because you know exactly what version of ExoPlayer you're shipping with your app. And the other great thing about ExoPlayer is that it's a very intensive library, so you could customize it and extend the player to your own needs. So if MediaPlayer and SoundPool don't satisfy your needs and you want to do more, then this is a great thing to look into. But it's a lot more complex to set up, and it's a lot more intricate to work with, so it's a little more complicated. So ExoPlayer itself is so complicated that there are like full-hour talks devoted to just ExoPlayers, and if you're really interested in playing other kinds of media, these are 2 really great talks to look into. So one other thing about audio is that we always want to be a good app citizen. This isn't something I personally had to worry about when I was building out our oven, just because our oven is just the one app on this one device, so we didn't have to worry about this. But if you're an app on a phone, you really want to think about how your audio is being focused and managed based on other apps in the phone, because you don't want to be taking over all the control for their audio so that other apps can't play any sounds. So what this means is that we really want to think about how audio focus works. So if you think about audio focus, it means that audio from different apps, they want to play sounds simultaneously. So the system doesn't really have control over what plays and what doesn't play. It just has this one continuous stream that apps give audio to so that they can play sounds. So what that means is that if your individual app doesn't properly handle audio focus, it results in a pretty bad user experience. So if we take a look at an example to see what this possibly means, If a user is currently in your app and your app is playing some kind of audio, either like just sounds based on what the user is doing or a soundtrack, and then the user goes into another app that plays some audio, if your app doesn't handle it properly, then both apps are now trying to play audio at the same time. And now they can't really tell what is being played at all because it's two different streams of audio coming at the same time, just playing without regards into each other. So what should actually happen in this case is that your app should request the audio focus. What this means is that you're letting the system know, oh, okay, I actually think I should be the one playing the main volume for now. And after you get this audio focus request, you should start the playback after you actually get this request successfully granted. And then from there, you should handle the audio focus changes through this method called audio focus change listener. And this way, apps can communicate with each other based on who is in charge and who is not. So when you do audio focus, there's a couple of intentions when you say, oh, okay, I want to gain audio focus, and this is why I need it. The first one is you want to gain it indefinitely. So this is mostly for media and podcast players because you're always going to be playing the audio in that case because you're going to be continuously streaming something. The second one is transient. That's kind of like temporary, which is mostly used in the case of a phone call. This is like, I don't know how long I'm going to take, but I'm going to be taking up an indefinite amount, and I don't want you to cut me off in any way. And the third option is audio focus may duck. So this is like something temporary, like a notification. So this is the most common example of this is probably if you use Google Maps and you have turn-by-turn directions, and every time it tells you, okay, now you should turn to lower volume, and that's what the duck means. So for sounds on the June oven, which is why I started looking into audio in the first place, we had common sounds versus special sounds. So this is kind of like common sounds would be something like tapping sounds or clicking sounds or back button sounds. Special sounds would be stuff like when your food is done cooking, that doesn't play very often, or your oven is done preheating, that also doesn't play very often. So those are special sounds considered. The other thing we had was themes. So we wanted to let users personalize their oven more. So one way we wanted to do that was through something called themes. So they could have like a blaster theme where sounds sounded more like video games, or they could have like a more muffled theme where sounds are a little more softer so it doesn't create too weird of an experience. And then there was also something called emergency sounds where like if your oven was like getting too hot and it would like be, okay, you should cool down your oven. These are emergency things that have really high priority because we really wanted to inform the user what was happening in this case. So for the common sounds like tap and cancel and accept and back, these were eagerly loaded into a SoundPool so that we could have low latency for playback because we didn't want the user to tap on something and then 5 seconds later or 1 second later be able to play a sound. That would be a really weird experience. So for these common sounds, we had to eagerly load them into a SoundPool so they could be faster played back. And all our other sounds are played with the MediaPlayer, which is the easiest way and the most common way to play sounds. Sounds were also able to request to be played immediately, for example, from the emergency sounds. So some of the problems we encountered, one of them was creating a pleasant experience on the sliders. As you remember, it was kind of weird where you had to play like 5 sounds at once, so it kind of sounded like your finger was sliding through a piano. So this was weird because we had to play multiple sounds at once and at the same time create a pleasant stream of one sound. So how do we play multiple sounds at the same time and still make it sound good? Another thing that was kind of hard was this idea of a wake sound. So if you imagine, what we were trying to do was that if you open your phone, so every time you tap on the power button on your phone, we wanted to play like a sound that says, oh, now this device is awake. So the problem with that is that we couldn't play a sound immediately after the device comes online because it hadn't prepared its media streams and its audio streams ready for us. So it would always play this like weird static sound because the system itself wasn't ready to handle sounds. And there was no callback for us to kind of listen to when the system would be ready to play sounds, so we had no way of dealing with this weird issue. Another problem we encountered was playing sounds when themes change, because as you can imagine, every time the themes change, we have to load in a whole new pool of sounds, and that makes it hard to listen to when the sounds are finished loading and ready to be played, to then play a new sound. And the last thing we kind of encountered was managing audio files. So all these audio files had to be packed into APKs in some way because we didn't want users to have to query the internet for an audio file. This meant like a really big APK size that ended up blowing up if we had multiple ABKs in our ovens. So how do we like manage these different audio files with different file sizes and still be able to create a good experience? So these were some of the problems we encountered. And yeah, that was most of my presentation. I think questions are going to be a little harder to take, but I'm happy to talk about the oven or about audio in general if you want to come out after the talk. So thank you for having me, and this is great.